Hello, hello, hello. Testing, testing, testing. Hello, hello, hello. Cool, that's perfect. Alright, yeah, moving on with the climbing system. I think I got some bugs solved last time, and maybe I need to start animating stuff. I did upgrade to 5.1 of the engine, Unreal Engine 5.1, I think. So I'm just going to right click on this, show more options, uh, switch Unreal Engine version, and I'm going to select this one. That should update all the files, like, well, I think it updates the U project file with the new version. And of course, when I go build it, it uses the new builder, I guess, which should flag any errors with things like uncompatible code that I've used. Go and open this up. Then you hate it when you're trying to stream and then your email address comes up. It's like, why are you logging me in like that? I hate that so much. And then you have to go and blur the video and everything. Such a pain. Okay, well that looks like it's going okay. Uh, cool. Based on your solution, you might need to install extra components for a full development experience. Alright, let's try that. Uh, okay, well, let's do that then. Shouldn't take too long. He says, waiting patiently. Okay. Ooh, that is quite slow. Really? What can we do whilst we're waiting for this to happen? I guess maybe we can have a little think about the corners, right? So, I know you have to watch the last videos, but essentially we have a wall and a wall, excuse me, and there's a climbing hold and a climbing hold, and the character can move between climbing holds. I've done that so I can do like some animated experience, and you can be very specific about where the character can go. But I like the idea of having this corner thing, so um, maybe we just like tick a box that says if a climbing hold is on the corner, and then well maybe it doesn't need to do that. You know what it needs to do is it needs to raycast. So if I did a climbing hold here and this one is like the closest climbing hold, then it won't get chosen because if I try to raycast to it and it's blocked by a wall, um, then it can't see it. And I think that should work actually quite well. And that will then allow me to put things on the corners, um, and I can just angle them. So like if you take the corner like this, the climbing hold would be like this, so that when the character animates to the corner, I guess it'll just have to slowly rotate. Well, maybe it just flick. I don't know. No, I think as it reaches it, as the character reaches that corner, maybe to slowly rotate the character around so it's facing on the normal of the surface here, the face. Though how do other games do this? So let's take a look at another game system. Maybe like Assassin's Creed, right? Because I think they do something very similar there. Let's see. Sure. Yes. Okay, Assassin's Creed. Climbing. Let's see what happens. Oh, this isn't real. Okay. I mean, this is sorry. This is real, but I want to know what happens in the game to see any of them doing it. So in this, I think in this case, clearly, yeah, clearly there's positions, right? So exactly what I want to do there. Yeah, that's what I'll be doing. So there'll be climbing holes there, or at least like lines on that object that allow it to interact with it. I wonder if there is a corner. It's funny because it is a little janky anyway. So I think I don't have to worry too much about how it looks around the corners, I think. Ah, here we go. Ah, so yeah, okay. So that was interesting. I saw it there. If we go back at this, so it's kind of just about to go and leap, and it hasn't changed the camera the character's angle yet, but then it does. So I think there's a transition here. If I go playback speed 0.25 for example. So that's a climbing hold. There's a climbing hold, and then he's still facing outwards against the wall. But then, ah, I see. No, it's a. It's very difficult to tell actually. It's very difficult to tell what they're gonna do. So that wasn't actually helpful because I don't think he actually crossed the corner, right? Let's try another one. Assassin's Creed climbing around corner. Let's try that. Oh, maybe I just watched this. I'm not sure if I just watched this. uh, but yeah, it's hard to tell quite what's going on there. Hmm. Upper cliff face is very difficult to see, so um, just trying to find one that goes around the corner. I mean, I think you can do that, right? I don't really remember these games. Um, let's see. How are we going? Okay, we're nearly there. See if this one does it. So that one's fine, because I understand that that's a different animation to go like that. Ah, here we go. Is it going to go around? Oh, come on, go around, go around. Yes! Yes, it's going around. Right. Ha, good find. So, let's go like this speed. So at what point does it snap through? Ah, okay, so it is an actual animation around the corner. That's a bit annoying. Yeah, or inverse kinematics? Yeah, it probably is actually. So the arm grips the other side. He's rotating, this arm's remaining, and so it's stretching the character around the corner. Okay, well this is a good one to and it looks like the legs do exactly the same, right? So it's the left one grips first, and then so left one grips, right one grips, and then this body rotates, but these are using inverse kinematics to lock that position there. So I think that's what's happening at least. Let me put this down. Yeah, okay, that's good. Right, what else can we do whilst it's installing? Because I'm trying to think of how we do that, and I think it's mostly just the inverse kinematic stuff. So um, that's going to be position position the arm. So let's say we've got this is our climbing holds, and the character's like, let's just get rid of this now. Sorry. And then this is the actual corner. And so the character's like out here. And so the arms are, just like that. And then as you press to go round the corner, this arm, let's call this L and that's R. L needs to go just like snap to here. So he's gonna do the reach, or as it reaches, or do you set the origin here and then swing the character around? Maybe that's how it works. So we could do that, right? Maybe that's how we should do it. Let's look at this again. It's something very. It's like a root motion animation, isn't it? So it's actually been animated around it. But then also it looks like he plants himself literally on the corner. No, he hasn't. No, it's I think it's a root motion thing. So going around a corner needs a root motion animation. Okay. You know, so we could do that, and the problem with that is that it's like down to the designers to do a lot of that work, or the artists. No, that's a shame. I don't know if I want people to have to do that sort of thing. What we could do is have this with that corner thing, as I said, right? So then it's just a character goes from here uh, like that, and that small rotation, you know, this little small rotation, um, sorry, I meant this rotation here. That might not be so obvious as the character goes round. And so then the character's kind of gripping onto the corner, like, you know, like that might make some sense. And I guess it also depends on how your game looks. I mean, maybe I can craft some options around this anyway. Okay, so at least we're inside the pack now. The solution. And let's go and let's see where we were. Aha, now it has to do the first build, right? For version 5. Ah, just a note, if you haven't seen it already, if you go to the Unreal Engine YouTube channel, there is a fantastic video I watched with like little tricks and tips that people should know but don't. And there was a couple in there I didn't know, so um, let's see, Unreal Engine Epic, just whilst that's loading. Excuse me, I apologise. Um, let's see if I can find it. Where is it? Yeah, here it is. 35 UE5 features you probably don't know about. So it's a good watch. You should definitely watch it. Missing project settings. Shader model 6 is required to use virtual shadow maps. Please enable this in project settings. Um, right. Help us to improve engine by telling us your industry. Uh, other. Okay, right. Well, so here's our character again. Let's move this camera back a little bit closer for my liking. Okay. And I think, yep, it's definitely snapping to the right things. Nice. Very cool. Okay. So we've got these on the corners. Now, if I were to rotate them 45 degrees, this is what I've just said basically. Can I rotate 45 degrees? I guess I'll have to go into here, right? Do 45. Oh, a bit confused now. Let's undo that. What we got? 180, so it's going to be 225. Oh, I see. The other way around. So it's going to be uh, okay. So now let's see if that still works. Yeah. So now it's interesting, isn't it? Because now it's on the corner. It doesn't actually look that bad, right? Clearly the thing isn't quite working because it's supposed to every time we go somewhere it's supposed to do face him to the normal, which is interesting. That is interesting. Let's see where we do that thing then, where we like rotate the actor. Gosh. We're getting somewhere. I think I want this over here. Yeah, it's better. Right, so maybe the climbing character. That's a movement. So maybe we want the climbing system component. Move to climbing hold actor. See any rotations here? There is rotations. Attach to climbing hold. This says to do rotation. So target climbing hold actor rotation. So does this get called every time? I can't remember. I just can't remember. Clearly not. So we want to do, what's this doing? Reach out to climbing hold. Guess that's being called from somewhere else. This one here. And this is on process climbing movement on the climbing player controller. Okay. So at this point, this should be called every time. Let's do that. It is. Is it literally called all the time? Is the question though. Make sure we know that. So I've done that now, but if I go back very quickly, I think it is. So I only care about it when it's actually gonna go and actually move. So as it's moving, it will call it, but then yeah, it doesn't call until it's ready again. Yeah. Okay, so it's in here. Signal that character should move to climbing hold. Okay. And this does that. And so it's on a tick, I guess. There's a tick that's happening. So we can find that. No tick here. So let's see where this is being used then. Oh, it is, yeah. Yeah, it is. Tick. Um, if it's attached to a climbing hold actor, scan thing, but otherwise move to climbing hold actor. So I guess that, there it is. If, yeah, so if that's got something in, it's going to do this. And then, let's see. There'll be some rotation here, right? Sector location, but not rotation. Okay, so this might be a good place to put it. And let's see, we had some rotation stuff going on somewhere else. Maybe I can copy that. Not there. Not there. I think we're out of places to look. So maybe it was in here. Yeah, it was. So it's this, basically. So if I go back, what does this actually do? Target climbing hold actor rotation is the climbing hold actor forward vector. Aha, get forward vector dot rotation though. And then that rotate, so the owner get the owner's forward rotation. See, that's new, okay. And then climbing hold rotation plus the axis rotation. Apparently poop. Doesn't help much, does it? Let's say adjusted rotation. Ah, but it's actually not used, this one, so it's just that. Okay, cool. And then we can go to this and remove that. And then character rotation, yeah, get the rotation, plus them together, and then set the rotation to 0 plus whatever that adjustment is. Right. So we've got it going on now. Oh yeah! Haha! We like that. Woohoo! Woohoo! Oh, that's funny. And what happens if I go on the correct way? Yes, he settles correctly. Okay, that's good. So this is rotating like a freak because um, so it's not that place. Where should I just change that? Was it in here? Nope. It was in here. So it's because this is actually doing the movement, then I don't think I need to do that. It's like it's only when I attach I need to do this. So session location, if the target climbing hold actor is true, then I'm slowly moving towards it, right? New location for actor is alert between that, right? Well, maybe I should alert rotation. No, it shouldn't do that, should it? So it's only when it commits to it. So let's see if you've got to do some here we go. So if it's less than that, do that. Otherwise, it's at the end. Reach climbing hold actor and then set the location, right? And need to do that before I clear it all out. Right, let's give that a try. That looks good. That does not. That does not. That does not. Is it going to keep changing? Interesting. Closer though. Now this 000 thing is probably wrong. I need to set it to the current rotation, right? So this is now, it's the target claiming hold actor rotation plus the character's rotation. Get the difference between them, or I don't want the plus them, I don't think. Like if you have that and then that, so the character moves between this and this, right? So this is the character, and this is the normal from the climbing hold. And in this case, we've got that. We've got but we've got the rotation of the forward vector of the climbing hold. Rotation of the. So I wonder what that actually comes out as. What kind of numbers are we looking at? So that's 180. So 180 in the yaw, and this is 90 in yaw. And so 180 in yaw is because it's yeah, okay. So it's literally how it starts. And I want to know. So it's going to be. So our character. Let's see. Oh, I think we need a pointer on this character. Let's go do that. Yeah, like that. Ah, is that arrow still there? No. So where's the arrow go? Hidden in game? No. And maybe the other one is just doing that as well. No, I can't actually add it to that. Okay, cool. Uh, okay, so that's interesting. So if I press it, then as it connects, it's fine, but then it mucks up. And I wonder, that's because it hasn't reached yet. It hasn't run this code yet. So this code is ruining it, right? Yeah, that code's ruining it. So where's the other rotator then? It's this. Has to be. Let's stop this. Go back here. Yeah. It's attached to climbing hold. And I guess if I run that, it doesn't run that again. But it's actually correct as we start off. because we're looking to the right. Oh gosh, these things, eh? I don't like this, and I think that's the problem. I just want to always be opposite of the actor's forward vector. That's all I want. So I need to get that rotation relative to where I start off. No. Oh God. Um, think. What do I need to do here? What do I need to do here? The character isn't facing the wall, that's one problem. So our rotations are based off of the mesh. Which is interesting. So maybe we need to start doing proper rotation of the character, which might make this a bit more easier to control. Yeah, let's do that. So move horizontal, process climbing movement, horizontal move. Add movement. And I think we want to use controller rotation yaw is equal to true. I think that's what we want. And just make sure that gets reset. On the character, rotation yaw, rotation to movement. Yeah, I did do that. Orientate. Maybe it's on the. No, that's it. Use controller rotation yaw. I'll tell you what. It might be that thing where I have to quit out again to get it to pick it up. Get a bit hot. 1 sec. Okay. So I'm going to go back to my character. Edit the character. Rotation. Use controller rotation yaw is now ticked. So what happens? I don't know if that's going to actually do anything yet. Yeah, it might have been just a. yeah, nonsense. But I do want that other thing on it, so I think it's orient rotation to movement. To see what happens here. It is actually moving this arrow slightly. So I'm doing something interesting. You can see it here, I think. Yeah. So that's interesting. So what we're doing on the character here, I'm adding movement input that way and add movement rotation. Oops. I guess I'm probably locking something off somewhere. What's this last one? Force. If true, always add the input. Ignore the result is move input ignored. Where is this being locked off? Well, that's good. At least he's facing the right way now, right? That's a good start. Um, but why is his move restricted? Because if I'm going right, then it should be rotating to the right because I'm not doing any like ticking thing. Uh, well, and add movement input is using the movement actor, the movement component. I don't think this sort of thing is being called, right? No, purely just a problem with the controller and thingy. And all I'm doing is that. Hmm. So something's locking off on this, and it's not to do with my code, I don't think. Something else. Yeah, okay. So that's very, very interesting. And we need to turn it off. So where did I get rid of that? It's in here. It was that one there. That's going to be false. And then we'll go and compile it again. Let's see if it picks it up. Yeah, it hasn't picked it up yet. Let's save that. And then restart. And then we'll rerun it. So I turned your block thing, I guess. Okay, cool. So that's probably a good sign. So now I have like a proper like thing to look at. So I think before I attach, I just want to flick the character to opposite that. So it shouldn't matter what direction the character is, right? It just shouldn't matter. It should just be the opposite of that. So I need to just find out the difference between where my character is looking and where my character should be looking. Well, the inverse of where the face is looking. So this is the climbing hold. I want it to be the inverse, so it should be looking over there. So I have to find out the inverse of this, so it's going to be this this angle, right? And then I need to just flick to that. So I need to get the current actor's location. So let's do this. It's going to be where was that thing? Here it is. It's this one, I think. No, this one. So I'm going to get the climbing hole's rotation. Then I want the character actor rotation. I want to find the difference between them. Let's see. Get difference between two vector rotations. Unreal Engine. So find look at rotation. Let's see the C++ version. What's that? Here it is. UKismet Math Library. Got it already. Awesome. So it is going to be I used to like it when you'd undo and then it would take you to where you're undoing to. I don't know why it's not doing that anymore. So we've got those two rotations, but let's see now. Find look at rotation. So this player location, I think I want this one. Oh, look at the location rather than the forward vector. Oh, that's interesting. No, no, no. We don't want that. We want the forward vector, I think. Hmm. Okay. Right, let me think about this then. So it's going to be it's going to be cosine well, because we have that forward vector which is going to be like -1, and that's going to be like whatever. That'll be like uh, a different. Oh, let's do it properly. So if we're going to go that way, it's going to be y. So it'll be 0, -1, 0, and this one will be positive x, is that right? Positive x, yep. So that will be 1, 0, 0. And then to find the difference between those, it'll be 1 times 0 times 0 plus 0 times 1 times 0, is that right? Can't quite remember now. Let's check it out again. We'll learn how to find the product, what is also called a scalar product because it yields a scalar quantity, not a vector. Is one way of multiplying vectors together. You are probably already familiar with finding the dot products in the plane 2D. You may have learned that the dot product of A and B is defined as the vector A times the vector B. Oh, it's times, okay. Geometry 1 can show that it can be calculated from the components of both vectors equals AX times BX plus AY times BY. Oh, I think I did that. Oh no. Oh, yeah, okay. So I've got to do 1 times 0 plus 0 times minus 1 plus 0 times 0, and then it's all divided by it's all divided by um, divided by the magnitude, and I can't remember what the magnitude is now. Oh god, is it really? Can't you just give me the bloody equation? Equation for angle between two vectors. Ah, that's the one. Okay, cool. Yeah, so it is the magnitude. Right, fair enough. We'll go back in here then. Maybe we could just do find magnitude of vector. So the magnitude of A is x squared plus y squared plus z squared square root of. For a vector, x1 plus y1 plus z1. Yeah, that does make sense. Let me just see if I've done this as well. dot length. Yeah, okay, it's x times x, y times y, z times z, and then the square root of it. So that makes sense. And then the dot product was what? Oops, that's plusing or something. Dot product was bitwise or statement, so it's going to be oh gosh. You're probably all familiar with finding the dot product in the plane 2D. You may have learned that the dot product of A and B is defined as A dot B, which is equal to the magnitude of A cross product of magnitude of B, cross product of cosine theta, where theta is the angle between the two vectors. So if we want to do, okay, with a little bit of geometry, one can show that it can be calculated from the components of both vectors. That's the dot product of A and B is equal to AX times BX plus AY times BY, where AX and BX are the X components of A and B. So you multiply these ones, I see. So you've got X, Y, Z, X2, Y2, and so then it's going to be X times Y times Z plus X2 times Y2 plus Z2 divided by X times X2 plus, is that right, plus? So this was plus, yeah, and then the magnitude was squared, so it's x squared plus y squared, x2 minus y1. For vector A, x, y, z, its magnitude is x1 squared plus y1 squared plus z1 squared. I need to sit down. Getting a bad back. I think I've done this thing like a million times now. It's so annoying that I always forget this stuff. But we got the equations here, so I should just look at this again. The dot product was no, we didn't. I see. But we want the magnitude anyway, so the length was what? And that can't be what I'm thinking of. So how is it that the length of the length is just x, y, and oh, I don't understand this. Magnitude of a vector formula. For a vector A equals x1i plus y1j plus z1k, its magnitude is x1 squared plus y1 squared plus z1 squared. What's I, j, and k? There is literally no mention of I, j, and k here. Don't like it. Vector equals xy. Vector equals 3 minus 5. Determine the components of the vector. Every vector can be numerically represented in Cartesian coordinates system with a horizontal x-axis and vertical axis. It is written as an ordered pair. Draw a vector triangle. When you draw the horizontal and vertical components, you end up with a right angle. Right triangle. The magnitude of the vector is equal to the hypotenuse of the triangle, so you can use the Pythagorean theorem to calculate it. Rearrange the Pythagorean to calculate the magnitude. The Pythagorean theorem is a squared plus b equals c squared. A and b are the horizontal and vertical components of the triangle, while c is the hypotenuse. Since the vector is the hypotenuse, you want to solve for c. X squared plus y squared equals z squared. B equals the square root of x squared plus y squared. Solve for the magnitude. Using the equation above, you can plug in the numbers of the ordered pair of the vector to solve for the magnitude. B equals the square root of 3 squared plus minus 5 squared. Yeah, this makes more sense. That's interesting. Okay. I do understand that. So if I do go back again, where are we doing this? So I want to do get that forward vector, get that vector. That's going to be an f vector. Oops. And then I want to do the dot product. So f vector dot product of target and that. be float. Just double check. It returns t. What? How does it return t? I don't understand. Dot product. And then I want the magnitude, so that's going to be mag of target, magnitude of that, magnitude of that. Oops. Oh, I'm not very good today, I have to say. I'm doing really, really bad. Is equal to this dot x minus oh, it should just be to power of 2. Can I do that? Plus the thing is though, how do you know which one it is? And that's why I think this is probably better, isn't it? x2 minus x1. x2 minus x. Then it's going to be, what's it, plus? Plus. So I guess I could just do this dot length, right? And then it's going to be this dot length. And then the angle between them. So now we have the length of this, we have the length of that. That means we got this. And then we want to know how much of an angle between it. So that's going to be that's going to be. So what did I do the other one? I think I've already done this again. Is it cosine that I did? It was cosine. Okay, let's just do that one. So that's the angle between them. So then I just need to rotate. I need to add actor rotation of that. Right, let's give that a try. got going on here. So dot product is that. Magnitude is that. Magnitude is that. So the thing is, the excuse me, the length of them's always going to be 1, right? But I need to know. I'll tell you what, I'm just gonna watch a video again. I just think I'm just so confused because I'm just an idiot basically. Um,
have a line, right? So this is sort of coordinate geometry speaking, right? Any line you like, let's just say its gradient is m. Now, I've just drawn this particular one just as an example. Okay, now, and the line itself. So I'm interested in this angle, an angle of elevation, if you like, okay? So how can I go about finding it? Well, what we'll do is we'll take advantage of some of our really simple Year 9 right-angled tree and construct a right-angled triangle here, okay? Really large. So, m. And that simply means that corresponds to the fact that gradient is rise over run, right? M over 1. So if this base down here is 1, and because the y-coordinate's m, that means that vertical height is m, okay? Remember what we were after was theta, so this is where that familiar result comes out from, right? Tan theta is opposite on adjacent, okay? So you often see it written in reverse. Morning, grab a sheet. M equals tan theta. Okay, so that's simple stuff. Now, by the way, I put this line just because of it was convenient. I put it through the origin. What would happen if I had, suppose it was x plus b, and it was like moved up or moved sideways or something like that? What difference would it make? Having a vertical or a horizontal shift, didn't it? Okay, great, you're actually right. Anywhere. Doesn't change this at all, okay? Because these distances and that angle will still relate to each other in exactly the same way. Sorry. All right, so let's take that, draw another diagram beneath this. Now, when you're looking at these two lines, right, so I should put some extra things on the axes. Generally what they're looking for is the acute angle. In fact, the question will usually be phrased, find the acute angle between these two lines. It's actually quite simple, okay? But in this case, the acute angle I'm after, the theta, right, is in between here. The acute angle is only one of them, okay? It's the same in both cases. Now, how can I relate this to that, right? Well, this angle is related to this angle for each line, okay? So since I've called it theta for that angle between two lines, let's call the other angles different names. That's beta, okay? So we know how to work out each of these lines if we know the gradients of the line alpha. Put them at different intersections. And let's call the other line's gradient m2. And of course it has a different y-intercept that corresponds to wherever it is, okay? That's exactly right. A second angle of a triangle, then that is the right thing. So what you're going to have here, right, beta, the exterior angle of this triangle, okay, beta is equal to theta plus alpha. Is that okay? And I might as well say exterior angle. So therefore, in this case, right, theta is actually equal to beta minus alpha, okay? All right, now how can I get gradient requires beta and alpha. Okay. Now, the great thing about this, the reason why this is actually useful and not that gross, is because I know what tan alpha and tan beta are.
You know what? I'm gonna have to stop because I am not feeling good. So I think I'll probably just continue watching this on my own, and then I'll do that thing. But I need to fix this problem, right? So yeah, I'm getting sleepy, so I'll stop the video here and we'll carry on another time.